Good day, ladies and gentlemen. This is Sarah van Grennen, aka Mr. VG, and we are now at video like 5 million. No, I'm just joking. I think it's about video 4 in this series handling grade 10 paper 1. What kind of questions can you expect in an algebra exam paper? Now, this specific question is about exponential addition and subtraction. And it will kind of slip in as part of, an algebra question. So in this one, there was question A and B, which we handled in the previous videos. This is actually question C. So if you didn't watch, me working through all of these and doing beautiful mathematical magic, please watch the previous video, because this one is now like this. And I asked it in a bit of a weird way that you might not be used to your teacher asking it, but this is the way that I know that in grade 11 and 12, we love to ask students how to do it. And I also put in the C2, which is a level 4 insight question in this, okay? It's not a usual kind of question. My students have coined these amazing kind of sums like C2, a Mr. VG special. So please go and try this sum yourself before you hit the play button again. So hit that pause button and go for it. So when I look at something like this, the question is simplify. Prove that K can be simplified. Now, whatever that answer is, I'm going to ignore it, okay? So I am going to ignore that completely, and I'm only going to use it as a check. Now, there's only pluses and minuses, additions and subtractions. So therefore, I've got to think about factorization. Grade 10s learn to almost eliminate things that are not necessary and get a game plan, okay? I know that a lot of you will just run into this question and hope and pray you do the best, okay? But please get a game plan going. Okay, so let's look at simplifying that by factorization. So first of all, I'm going to split up my exponents. Now, this is not a necessary step, but it's a step that I love to do nonetheless. So in other words, I split that 3 up there and that 3 up there, okay? Why do I do that? Because it makes my factorization easier. So this means that I put a block around whatever is common, okay? Because a lot of times it's going to be common factors. Not always, but a lot of times, okay? So when I look at this, I can take out the block common. In the first, at the top, you will see wherever there was a block, a 3 to the x, I put a 1 there, just so that I don't forget it. But what does the block actually represent? The block represents 3 to the x. Now go and try the bottom one yourself as well. Now I'm going to use a different color block. I'm going to use a red block. So in the denominator, I'm taking out the red block common. And wherever there's a red block, I put a 1 where I take it out common. So what does the red block represent? 3 to the 2x. Now let's simplify those brackets, okay? If I simplify the brackets, I get 7 over negative 2. Now, ladies and gentlemen, okay, here's where the bells must start ringing, okay? Look at where you want to go. You want a 7 over negative 2. Negative 7 over 2. I like it. I'm going in the right direction. Now, what must I do with those 3's? What must I do? Well, I can apply law 2. So I can say that is 3 to the x minus 2x. and I've just moved the 7 over negative 2 to the front. Now, what is 3 to the x minus 2x? Well, that's just 3 to the negative x. Is that the answer I'm looking for? Yes, it is. So in a sum like this, forget about where you want to go at the beginning. And as you start getting into your final stages of the sum, then you start comparing it backwards. Where did I want to go? And then you always compare. Now, one of the most important reasons why they love to ask these questions is for question C2. That even if you couldn't do C1, you can still attempt C2 because you know what K is equal to. So in other words, K is negative 7 over 2 times by 3 to the negative x. But also, remember what this first little restriction means. If x is an element of natural numbers, in other words, if x is either 1, 2, 3, 4, 5, up to infinity, okay? So those are my options for x, okay? So how am I now going to get a minimum value for k? Do I even know what the heck k is? And I can tell you most of you are looking at this and going, no, I don't really know what it is. But actually you do. But we'll handle this when we start doing the fancy stuff. Let's just go bull in a china shop, okay? Let's just substitute x with those different values in there and let's see what is happening. Let's find a pattern. So let's make x equal to 1 and let's see what's happening, okay? If I make x equal to 1, I get an answer of negative 7 over 6. Okay? If I make x equal to 2, I get negative 7 over 18. Okay? If I make x equal to 3, I get negative 7 over 54. Now, ladies and gents, let me just quickly hit the pause button for this video. Okay? Not you, me. Okay? I'm going to continue talking. So don't hit the pause button and wait for the magic to happen. As I was doing matric marking in this past month, one of the most important things that the examiner, the person that actually set up a national paper, said to us was, whenever you are wanting to interpret or prove or whatever, always do calculations, especially in a sum like this. Just plug in those x values. Just throw it into your equation. Substitute it in. And let's see what happens. Maybe there's a pattern. Maybe there's some magic that happens. And only when you've done that do you now try and interpret. Okay. So let's quickly look at those values. Now I'm going to take it from fractions and putting it into decimals. If I look at the decimals, those are my values. Okay, now you can put it in your calculator and get those values. If you look closely, the minimum is negative 1.16 recurring. Because remember, it goes from negative 1.16, and then it goes up. It goes in the positive direction to negative 0.38 recurring. And then it goes even more positive to 0.1296. So what is the smallest value, the most negative value? And that is negative 1.16 recurring. Okay. But now, does it make sense? Now, this is one of my favorite questions to ask my grade 8s to 12s. All of my students. Does the answer make sense? Well, let's look at K as if it is a graph. What kind of a graph is this? Well, it's actually an exponential graph, which lies beneath the asymptote. You can go and draw this graph, and it kind of looks like that, okay? Now, I draw dotted lines simply because they were talking about natural numbers, so it's not a connected line, okay? But I'm not going to worry much about the connected and disconnected, but it is an exponential graph. And if I tell you that x only starts from 1 and goes in the positive direction, it means I can ignore all of those values there and only look from 1. So what is the lowest x value you get, or the lowest y value you get? And that is negative 1.16. It goes up from there. So it's not just algebraically does it make sense, but even graphically it does make sense. Wow, this was fun. Whoa, ladies and gentlemen, don't forget to think graphically. Well, this is Mr. VG signing out. I hope you're going to have a beautiful and amazing rest of your day. In our next video, we are now going to start looking at applying algebra into some beautiful, beautiful mathematical spaces. So sign in to our next video where we're going to mix algebra knowledge with equations. I love it. Have a beautiful rest of your day. Keep well. Cheers.